In this video, we will interpret the phase diagram of water and carbon dioxide and determine and explain the heating and cooling curve of a substance. Kapag ang matter ay nabago mula sa isang state to another, halimbawa, ang solid ay nag-change into liquid, ang phase change ay tinatawag na melting. Liquid na nag-change into solid, ang phase change ay tinatawag na freezing. Kapag naman ang gas ay nag-change into liquid, ang phase change ay tinatawag na condensation. Kapag ang solid ay nag-change directly sa gas, ito ay tinatawag na sublimation, at kapag gas to solid naman, ito ay deposition. Isang dahilan ng pagkakaroon ng phase changes ay ang pagtaas ng temperature. Alam natin na may tinatawag na intermolecular forces sa pagitan ng mga molecules. Ito ay attractive forces that held the particles together. At mas mataas ang attractive forces kapag condensed phases katulad ng liquid at solids. Dahil ang mga particles ay magkakalapit, may posibilidad silang mag-vibrate in a fixed point. Ano ang mangyayari sa solid kapag tumaas ang supply ng heat? Una, magreresulta ito ng pagtaas ng kinetic energy kaya mai-intensify ang vibration ng particles. At kapag mas tumaas na ang supply ng heat kaysa sa intermolecular forces na nag-hold sa solid particles, magsisimula na din masira ang solid lattice formation at ito ay matutunaw. Mababawasan ang molecular order at magsisimula na silang mag-slide past each other. Ito ay nasa liquid phase na. At ano naman ang mangyayari kung patuloy na mag-i-increase ang isinusupply na heat? Magre-resulta naman ito ng pag-overcome sa intermolecular forces between the liquid particles at magkakos ito ng paggalaw at pag-collide ng particles forming a gas or vapor. Karamihang dumadaan sa two-step process bago maging gas. Ngunit may mga solids na diretsyong nagiging gas or vapor at hindi na nagme-melt kapag nagkaroon ng sufficient energy. Ang tawag sa prosesong ito ay sublimation at ang example ay ang dry ice, ang solid form ng carbon dioxide. Ang bawat substance ay may mga tiyak na kondisyon kung saan nagaganap ang kanilang mga pagbabago sa phase o ang phase changes. Ang mga kondisyong ito ay maaaring makuha mula sa mga phase diagram. A phase diagram is a graphical representation of the pressure-temperature relationships that apply to the equilibria between the phases of a substance. Ito ay kapaki-pakinabang sa pagtukoy ng kombinasyon ng temperature at pressure kung saan ang isang substance ay mag-i-exist bilang isang solid, liquid o gas, o ang mga kondisyon na mayroong dalawang phases exist in equilibrium. Dalawang karaniwang pinag-aaralan ng mga phase diagram ay ang water at carbon dioxide. Narito ang isang illustration ng isang phase diagram. Tingnan natin ang phase diagram at by looking at it, ano-ano ang mga information na maaari nating makita. May nakalagay dito na solid, liquid, and gas. In other words, makikita natin dito ang mga phases at different temperature. Makikita din natin dito ang temperature at which one phase exists and changes. Narito din ang pressure at which one phase exists and changes. Papansin din natin ang dalawang point na tinatawag na triple point at ang critical point. Pag-aralan na natin ang phase diagram ng water. The solid curved lines in the diagram give the temperatures and pressures at which two phases exist in equilibrium. Equilibrium means that the phase change from phase A to phase B occurs at the same rate as the phase change from phase B to phase A. Ang ibig sabihin nito, ang lines na ito ay nag-indicate ng conditions under which two phases of matter coexist at equilibrium. Makikita natin ang line AB which shows the temperature-pressure conditions for solid-gas equilibrium. Ang line BC naman for liquid-gas equilibrium at ang line BD for solid-liquid equilibrium. All points that do not fall on any of the lines in the figure represents conditions under which there is only one stable phase. For example, dito sa point na to, so isa lang yung phase dito, ito ay liquid. Dito naman sa point na to, ang phase lang dito ay gas. At dito sa point na to, ang phase lang dito ay solid. Ang phase diagram ng water ay mayroong negative slope ng solid-liquid boundary line. Ang ibig sabihin nito, ang melting point ng ice decreases as the external pressure increases. Ang behavior na ito ay namamanifest dahil ang density ng ice ay less than that of liquid water at the melting point. So, the maximum density of water is observed to be at 4 degrees Celsius, the temperature at which liquid water freezes and its volume increases. Note that the normal boiling point of water is 100 degrees Celsius and its normal freezing point is 0 degrees Celsius. Point B is referred to as the triple point. Ang ibig sabihin nito, yung tatlong phases coexist in equilibrium, yung solid, liquid, and gas. The triple point of water is at 0.01 degrees Celsius and 0.0060 atmosphere. Point C is the critical point at ito naman ang temperature pressure condition at and above which the vapor of the substance cannot be liquefied no matter how much pressure is applied. The critical point of water is 373.99 degrees Celsius at 217.75 atmosphere. This figure illustrates the phase diagram for carbon dioxide. At pressures around normal atmospheric pressure, carbon dioxide can be either solid or a gas depending on the temperature. Kapag 1 atmosphere, solid carbon dioxide is in equilibrium with the gas at 78.5 degrees Celsius. As solid carbon dioxide warms above this temperature, it sublimes rather than melts. So, hindi ito nagme-melt. Hindi na siya dumadaan sa liquid phase. Hence, the term dry ice is used for gaseous carbon dioxide. Ang triple point ng carbon dioxide ay negative 56.7 degrees Celsius and 5.11 atmosphere. Ang ibig sabihin nito, ang carbon dioxide ay hindi maaaring maging liquid kapag ang pressure ay less than 5.11 atmosphere. From the phase diagram, makikita natin na ang carbon dioxide can be converted to a liquid at 20 to 25 degrees Celsius by applying moderate pressure on the gas. This is how carbon dioxide is regularly shipped to industrial companies and laboratory. The critical point of carbon dioxide is 31 degrees Celsius and 73 atmosphere. Once the critical point is reached, distinct liquid and vapor phases are no longer evident. This homogeneous phase is called supercritical carbon dioxide. A supercritical fluid is a substance that has a temperature above its critical temperature and a density near its liquid density. Punta na tayo ngayon sa ating lesson number 2, heating and cooling curves. Ano mangyayari sa temperature of a block of ice when you put a Bunsen burner underneath it? Ang isipin natin ay the temperature goes up smoothly, pero hindi iyan ang nangyayari. Tingnan natin ang illustration. Ito ay ang graph of temperature against time at ang tawag dito ay heating curve. Let's look at the heating curve of water. Notice that in general, the temperature goes up the longer the heating continues. However, there are two horizontal flat parts. Ano yung mga flat parts na yon? Tingnan natin ang graph. Ang flat parts na tinutukoy ay ang segments BC at DE. At nangyayari ito kapag merong change of states. The plateaus are called phase changes. The first change of state, yung segment BC, ay melting. At ang temperature stays the same while a substance melt. For water, the temperature is 0 degrees Celsius, dahil ang melting point for water is 0 degrees Celsius. So over the course of this line segment, both liquid and solid exist in various ratios, starting at 100% solid and ending at 100% liquid. Yung pangalawa namang change of state na makikita natin dito ay ang segment DE. Dito naman ay boiling or changing from a liquid to gas. The temperature stays the same while a substance boil. So for water, this temperature is 100 degrees Celsius because the boiling point of water is 100 degrees Celsius. So over the course of this line segment, both liquid and gas exist in various ratios, starting at 100% liquid and ending at 100% gas. Ang iba't ibang substances ay mayroong iba't ibang melting points and boiling points, but the shapes of their heating curves are very similar. Heating curves show how the temperature changes as a substance is heated up. Cooling curves are the opposite. They show how the temperature changes as a substance is cooled down. Katulad din ng heating curve, ang cooling curves ay mayroong horizontal flat parts kung saan ang state changes from gas to liquid or from liquid to solid. Tandaan natin that energy changes since temperature is a measure of average kinetic energy, and any change in temperature is also a change in kinetic energy. So lahat ng diagonal line segments doon nakita nyo sa heating or cooling curve ay nagpapakita ng temperature change. At therefore, ito ay may napapakita din na change in kinetic energy. So during these regions, a single state of matter exists and the sample is either getting hotter or cooler. Sa mga horizontal line segments naman, there is no change in temperature. So, yung kinetic energy, syempre, ay remains constant.